Hello, Algebra students. Mr. Lawrence here with your part 2 of operations with scientific notation. Actually, it's just part 2 of scientific notation. We're going to be doing operations, which we haven't done before. And I'm going to start off with multiplication and division because they are so simple. Addition and subtraction are pretty easy too, but these are very similar to the problems we were doing, like 3x to the 7th times 4x to the third. Well, you would do 3 times 4 to get 12, and then you do x to the 7th times x to the third and get x to the 10th, right? Okay, so the first thing I'm going to do is I'm going to multiply 321 by 11. Now, you might say, well, Mr. Lawrence, there's decimal points in there. I know there are. I'm just going to ignore them for now, and I'm going to pay attention to them later. Put them in here in green. Okay, now I know a really cool trick for multiplying by 11s. Let me show it to you really quick. If I want to do 25 times 11, well, it's going to begin with a 2, it's going to end with a 5, and 2 plus 5 is 7. It's going to be 275. You can check that if you like. If I have to do 1,243 and multiply it by 11, well, I'm going to get a 3, then I'm going to get a 7, then I'm going to get a 6, and then I'm going to get a 3, and then I'm going to get a 1. If you're wondering what I'm doing, 4 plus 3 is where the 7 came from. 2 plus 4 is where the 6 came from. 1 plus 2 is where the 3 came from. And this one was here, and the 3 was there. Now you do have to be careful, because if you have something like, say, 68 times 11, well, you're going to get an 8 there, but you're not going to have a, well, I'll put the 6 there temporarily, but 6 plus 8 is 14. I put the 4 down, but I got to carry the 1, so it's really a 748, not a 648. Okay, so you got to watch for carrying. So I'm going to use that little trick to help me multiply 321 by 11. Well, I know I'm going to get a 1. 1 plus 2 is 3. 3 plus 2 is 5, and a 3 to lead. Now I'm going to count how many digits are behind my decimal points. Well, there's 1 right there, 2, 3. So I need 1, 2, 3 numbers behind my decimal point. See how simple that is? 3.531 times 10, and I've got 10 to the 8th times 10 squared, which will be 10 to the 10th. And there you go. I just multiplied in scientific notation. Just a little hint, you always want to check this number here and make sure the decimal point's where it needs to be. You might have to change it when you're done. Okay, let's look at problem B here. Again, I'm going to multiply the 5 and 2/10 by 3. And, 52 times 3, well, 6 and 15. There was a decimal point there, so there's one digit. So there's one digit. So right now I have 15.6. 10 to the negative third times 10 to the 8th will be 10 to the 5th, right? But that's not my answer because the decimal point's in the wrong place. I need it here. So I'm going to give the answer of 1.56. But how did I change this? Well, I divided by 10, right? Since the red number turning into the green one got smaller, my exponent has to get larger. Otherwise, I don't have the same number. It's like saying if I do 2 times 10 to the first, well, that's 20. But if I do 20 times 10 to the first, I won't have 20 more, so I could do 10 to the 0, and I'll still have 20. Notice, this number got larger, the exponent got smaller, right? If the decimal part of the number gets smaller, then the exponent's got to get larger. Okay, let's talk about division. It's very much the same thing. I'm going to divide here, and of course I'll subtract exponents there. So I'll go ahead and do this part first because it's so simple. Okay, 1.44 divided by 1.2, well, that's the same as 12 going into 14.4. So it looks like it's going to go 1.2 times, right? Okay. So we get 1.2 times 10 to the second. All right, if I have, say, 1.69, and I'm going to divide it by 1.3, well, that's the same as 13 being divided into 16.9. So it's going to go 1, 13, and it's going to be 39, and it's going to get a 3 there. I'm going to get a 1.3 times 10. Now I have to subtract exponents, so it's going to be negative 3 minus negative 8. Well, that's going to be 10 to the 5th. All right, and of course you can do a lot of this on your calculator, but I really expect you to know how to do this. If you don't know, come on in and see me. Okay, now addition and subtraction are different. They aren't quite as simple. They have a little rule to them, and the rule is the exponents must match before I can add or subtract. Okay, this answer is not 7.29. No, 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 no. If you are thinking it's 7.29, please ask your mom or dad to boil some pasta, and when it's nice and soft, beat yourself with it. Okay, here's what I'm going to do. I'm going to change this to a 3. But I can't just hocus pocus change it. It got bigger by 100, right? Didn't I multiply by 10 squared? So I have to divide by 10 squared. So it's going to go whoop, whoop. So what I have really is 6.18 times 10 to the third. And then this number, I'm going to make sure to line up my decimal point. I have a 0, a 1, and then 2 more 1s times 10 to the third. If I want, I can put placeholder zeros here without changing my number. And now I'm ready to add 10 to the third. And I got 1, 1, 9, 1, and 6. And there we go. Remember, the exponents have to match. Okay. On this one, I'm going to change the negative 5 to a negative 3. Now remember, that would be like multiplying by 100. That got larger, right? So if I multiply by 100 on this part of the number, I have to divide this part of the number by 100. Otherwise, I change the number. So we have 3.21 times 10 to the negative third. And again, I'm going to line up my numbers. 0.0563. Put some placeholder zeros in. This will be times 10 to the negative third. These 10 to the negative thirds, they really act like variables. They're not variables, but they act like x cubes or x to the negative thirds or y to the sevenths. They behave very much the same way. I'm going to get a 3, a 6, another 6, a 2, and there we go. I am in scientific notation. All right, now, same thing with subtraction, very much the same thing. I'd like to turn the smaller exponent into the larger one. So I'm going to turn that into an 8, which means I multiplied by 10 to the first, so I'll divide by 10 to the first. So my number is 8.64 times 10 to the 8th, and I'm going to subtract 0.43 times 10 to the 8th. All right, I'm going to get a 10 to the 8th here. 4 minus 3 is 1, 6 minus 4 is 2, and then 8 minus 0 is 8. And then there you go. All right, that's your lesson for today. You may want to get a little extra practice with that. Think about what was going on there. I know I threw a lot at you. All right, Mr. Lawrence signing off. Good night, everybody.